Hello dear students, welcome to another session of important question discussion from the chapter Equilibrium. So we have completed hydrocarbons, thermodynamics, some important chapters already. So we are going for the next important chapter, Equilibrium. In this equilibrium chapter, you may studied about what is the expression for Kc, right? Equilibrium constant. What happens to Kc when you reverse an equation, when you multiply with a number, and also what is reaction quotient Qc, Kc Qc relation, and the Kp Kc relations, right? The derivation and all you may study. What is acid base concepts, how to calculate pH, pOH and all, and what are the buffer solution, what is common ion effect, solubility product, Le-Chatelier principle, what is conjugate base, conjugate acid, many theories you may studied in this chapter. So in this lecture, we are going to understand what are the important questions from the chapter chemical equilibrium in detail. So carefully all of you be ready with a book and try to find the answer, and the numericals and all final answer I will provide it. Just cross check with the answer. Okay, let's go for a simple question in the beginning. Write the equilibrium constant for the following equation. They given an equation AA plus BB gives CC plus DD. What is the expression for equilibrium constant Kc? You know that equilibrium constant is equal to product concentration, right? Product concentration divided by reactants concentration. Product by reactant. Am I right? So Kc is equal to, what are the products here? C and D, right? So we can able to see that concentration of C raised to C into concentration of D raised to D divided by concentration of A raised to A into concentration of B raised to B. Yes or no? So Kc is nothing but concentration of product, molar concentration of products on the numerator, molar concentration of the reactant in the denominator, each term raised to the power. The power is what actually the coefficient in the balanced equation, right? And you know that whenever you taking the molar concentration of solid or something, we will take it as unity, right? Yes, concentration of solids, we take it as what? Unity, 1. So we can take Kc as per this equation like this. Second question, write the chemical equation. This is reverse question. Here they given an equation and they asking to write Kc. In this question, they given Kc and they asking to write the reaction. Clear all of you? So Kc is given as Hi square by H2 into I2. So you know that this numerator is product, the denominator is reactant. So what are the reactant here all? Hydrogen plus iodine. Give you what? Hi. What is that power represent? That's a coefficient, right? So H2 plus I2 gives to Hi. Okay, starting from the simple question first. Next one. We know about the relation between Kp and Kc, right? You know that Kp and Kc. Right, Kp and Kc. What is Kp? Kp is nothing but the equilibrium constant in terms of pressure. Because, you know, this is only applicable for gaseous system, right? You know, gaseous, their concentration we can express in pressure. So, instead of Kc, what we can use? Kp. So, Kp and Kc, how related? The derivation we can discuss. Kp equal to Kc into RT raised to delta Ng. That you studied. Kp equal to Kc into universal gas constant into temperature all raised to delta Ng. What is delta Ng? You know, delta Ng is the number of gaseous product minus number of gaseous reactant. Number of gaseous product minus number of gaseous reactant. So tell me, the question is very simple. What is the delta N value for this reaction? Dear all, this is reactant and this is product, right? In product side, how many gaseous products you have? You know, this is gas, here 1 ammonia, 1 HCl. So total you have 2 moles of gas. So 2 minus, what is the number of reactant, gaseous reactant? This is solid here all. If solid, liquid, other state, you know, please don't take it. Only gaseous product minus gaseous reactant. There is no gaseous product. So what it is equal to 2. Okay, so in this question, they're just asking what is the value of delta Ng. That is 2 minus 0, that is 2. Clear all? Next one. In the case of the reaction H2 plus I2 gives to Hi, the standard free energy, you know, Gibbs energy, they given as 0, greater than 0. Greater than 0 means what? They are positive, right? Okay. If so, what about equilibrium constant? They given Gibbs energy and they asking you what is the value or the general value of equilibrium constant Kc. What is the relation between Gibbs energy and equilibrium constant? Delta G equal to minus 2.303 RT into log Kc. This is the relation between Gibbs energy and equilibrium constant. They already said Gibbs energy is positive. They're all Gibbs energy positive mean what happened to Kc? Kc will be what? Negative, because Gibbs energy is negative of log Kc. So Gibbs energy positive mean the Kc value will be negative. So what is the answer? Option 4, K value will be less than 1. That means minus. Just take in the relation, identify the answer. Clear all? Next one. What is the pH of? You may studied what is the pH calculation equation, right? pH. pH is equal to negative log of hydrogen ion concentration or hydronium ion concentration. Correct, right? pH equal to negative log of H plus concentration. So what is this species here? 0.002 molar HBr. Right. You know, HBr can give only one H plus. Yes, one H plus ion, right? So what is 0.02 molar mean? We can write it as 2 into 10 raised to minus 3. Right? 0.02 we can write it as what? Minus log of 2 into 10 raised to minus 3. How to simplify this one? Minus, you know, log A into B is log A plus log B. So we can write it as log 2 plus log 10 raised to minus 3. Minus of log 2 value they will mention in the question or the teacher will provide that one. So log 2 is, just to mention all of you, the log 2 value it is, log 2 is equal to 0.3010. Okay, 0.3010. Almost you can take it 0.3. So log 2 is 0.3010 plus log 10 raised to minus 3. Log 10 to the power any value, the value is the 1. So log 10 raised to minus 3 is minus 3. Minus 3. So sign very careful dear all. Minus minus get plus. So 3 minus 0.3010. Very close to the answer is around 2.7. Right? Answer is around 2.7. So for reference, the value is already given. Just cross check it all. So pH is calculated. You know, pH is the one used to identify how much the acid is strong or weak. Higher the low, you know, pH value, right? pH scale, you know, 14, right? 14, middle is 7, below 7 acidic, more than 7 basic. pH is calculated by negative log H plus. So H plus concentration we substituted. This is log A into B. Log A into B is log A plus log B. So log 10 raised to minus 3 is minus 3. Log 2 value will provide and calculate the answer. Clear all? pH calculation. Next one. BF3 does not have proton, right? They do not contain H plus ion. But upon reaction with NH3, it still acts as an acid. Why? Dear all, you know BF3, let me take ammonia, okay? What is ammonia? NH3. NH3, ammonia contain lone pair, you know very well. Whereas BF3 means, this is the situation, right? BF3. So ammonia when combined with the BF3, what happened? That's a question. Let's see. Ammonia contain a lone pair. You know, lone pair donors are called Lewis base, right? Lewis base. You may study 3 theories consider about acid and base, right? Which all Arrhenius concept, Lowry-Bronsted concept and Lewis concept. What is Arrhenius concept? Acids are H plus donor, bases are OH minus donor. What is Lowry-Bronsted concept? Acids are H plus donor, proton donor, and bases are proton acceptor. What about Lewis base and Lewis acid? Lewis bases are electron pair donors and Lewis acids are electron pair acceptor. Dear all, nitrogen having a lone pair, so it can donate lone pair, so it can act as a Lewis base. Whereas BF3, see the central atom boron. You know, boron contain 3 bonds right here. Boron having 3 bonds. You know, 3 bonds mean how many electron? 6 electron. So this boron contains 6 electron on which? So it's electron deficient or electron rich? It's electron deficient. Why? Why BF3 is electron deficient? Because it do not completed the octet. It need 2 more electron, right? So BF3 is electron a deficient compound, electron deficient. So what happened here all? NH3 is electron rich, lone pair is there, BF3 is electron deficient. So what happened? The nitrogen donate the lone pair to B and they will form a bond. How can we express NH3? We can express like this one, NH3, you know the lone pair donated, right? Lone pair donated to what? BF3. Oh, you know what is this arrow? What is this bond represent? What type of bond is this? Coordinate bond, right? Coordinate bond. Why coordinate bond? Because both of the electrons are taken by one element. They are not sharing. They are not sharing mutually, right? Both of the electrons are taken by nitrogen and giving to benzene. So that is what? And sharing. This is called coordinate bond. So conclusion, BF3 actually do not contain any proton. BF3 do not contain any proton. It do not contain any H plus ion. Because it's a BF3 is electron deficient. Since it is electron deficient, it can combine with what? Lewis what? Lewis base. So nitrogen donate lone pair, BF3 accept electron. So nitrogen act as a Lewis base and the BF3 act as a Lewis acid. BF3 act as a Lewis acid. So even though BF3 do not contain proton, why it act as an acid here all? It act as a Lewis acid because it is electron deficient. So they will take electron, they will accept electron from NH3 and through the bond formation, coordinate bond. So this is the answer for this question here all. Just pause the video, read the question once again, just watch it. Okay, next one. How are Kc and Kp related in this particular reaction? The reaction is N2 plus O2 gives to NO and all are gases, right? What is the relation between Kp and Kc? Kp equal to Kc into RT raised to delta Ng. This is the equation for Kp and Kc relation. Here, can you calculate delta Ng first? What is delta Ng? Number of gaseous product minus number of gaseous reactant. Tell me, how many gaseous product you have? How many gaseous product you have? Totally you have 2 moles, right? You have 2 moles gaseous product minus. How many gaseous reactant we have? 1 nitrogen combined with 1 oxygen, right? 1 nitrogen combined with 1 oxygen. Both are gases, right? So 1 nitrogen, 1 oxygen means total 2 moles is equal to 0. So delta Ng 0 means substitute here RT raised to 0, it become 1. So Kp equal to Kc. So, for a reaction when delta Ng is 0, then Kp equal to what? Kc. Correct? This is the relation. Next one. What does equilibrium constant Kc tell us about the mixture? You may studied what happened Kc value greater than 10 cube, what happened Kc value less than 10 raised to minus 3, what happened Kc value in between 10 raised to 3 to 10 raised to minus 3. Yes or no? You may study the application of Kc. When Kc value greater than 10 cube 1000, we can able to say that products are predominant than reactants in the mixture. If Kc value greater than 10 cube, we can able to say that products are predominant than reactants, or it's more focused towards products. When Kc value less than 10 raised to minus 3, just opposite, reactants are dominated than which one? Products. This is second. And what happen if Kc value between this range? There will be an appreciable amount of both reactant and product. Once again, by looking the value of Kc, we can able to say that whether product or reactant more in the mixture. If Kc value greater than 10 cube, products are predominant. Kc value less than 10 raised to minus 3, reactants are predominant. When Kc value between 10 raised to 3 to 10 raised to minus 3, appreciable amount of both reactant and product will be there. This is the idea getting from Kc value. Clear all of you? Next one question, numerical one. The following concentrations were obtained for the formation of ammonia from nitrogen and hydrogen. What is the equation? You know, nitrogen combined with the hydrogen, we get ammonia. While balancing, N2 plus 3H2 gives 2NH3. Question, they given the concentration of nitrogen, hydrogen, amine calculate equilibrium constant. Direct substitution, dear all. You know how to calculate Kc? Product. What is the product? Ammonia square by, what is the reactant? Nitrogen into hydrogen, H2, the cube. Right, the coefficient we take it as the power. Substitute the value. Ammonia concentration is given 1.2 into 10 raised to minus 2 square divided by, what is nitrogen concentration? Nitrogen is 1.5 into 10 raised to minus 2 into, what is hydrogen concentration? 3 into 10 raised to minus 2. 3 into 10 raised to minus 2 the cube. Okay, all, just nothing but Kc value, we substituted product concentration by reactant concentration. All values are given. Don't forget to multiply with the, or take the power, okay, the coefficient, don't forget. Final answer, all of you calculate it. It's around 3.55 into 10 square. 3.55 into 10 square, or 355. So all of you calculate once again the concentration of which one? The value of Kc for this equation. Directly substitute on numerator and denominator for the concentrations. Next question, the value of Kc 4.24. They already given as Kc equal to 4.24. Okay. What is the reaction given? CO plus H2O equilibrium with CO2 plus H2. Calculate the equilibrium concentration. We need to calculate the concentration of carbon dioxide, hydrogen, carbon monoxide, H2O. All of their concentration we have to calculate at equilibrium. Okay, and they said if only CO and H2O are present initially with a 0.1 molar concentration. How to answer this type of question? Carefully listen. NCERT question. Answer already given here for your reference, dear all. Just to cross check it. Okay, the steps let me explain. This is the reaction given. How much is initial? We have initial concentration. Initial. See, initial how much CO and H2O is there? They said 0.1 molar, right? So 0.1. Initially, you know, when you're starting a reaction, we have only reactant, no product. So product will be what? 0, 0 initially. Now at equilibrium, what is the concentration? Can you tell me, dear all? At equilibrium, suppose X amount of carbon dioxide form, X amount of hydrogen form. These both are 1 mole, right? So XX. So at equilibrium, you know what happened? This is initially you have reactant, initially no product. After some time, when it's reached equilibrium, some amount of products form. Let's consider XX. Then here what is left? This XX formed from this reactant, right? So what is left? 0.1 minus X and 0.1 minus X. This is the one we left in this mixture, the solution. So this is the concentration at equilibrium. And what is the value of X? We have to substitute here. That is the final answer. So how to calculate X value? Take the Kc expression, dear all. You know Kc is equal to product by reactant. What is the product? Carbon dioxide, right? Product is carbon dioxide and hydrogen, and coefficient is 1, and carbon monoxide and H2O. Substitute the value. Carbon dioxide concentration is X. H2 concentration also X by, here it is 0.1 minus X into 0.1 minus X. That is 0.1 minus X square. So we can say, you know, Kc value already given, right? Kc value already given 4.24. So 4.24 is equal to X into X, X square by 0.1 minus X, 0.1 minus X whole square. Clear all? Let us simplify. Either we can perform this calculation of X by quadratical equation, X equal to minus B plus or minus, that you can take it. Or here it's very easy. We can take square root on both sides. Okay? Take square root on both sides. When you take square root on both sides, what is the square root of 4.24? Approximate. You know, square root of 4, 2. So 2 point. Square root of 0.24. So square root of 4.24 we need, right? So square root of 4 is 2 point. What is 0.24? You know, 25. 25 root 5. So 0.24 is very close to 5, right? We can take it as 0.05. Okay. So taking the square root on both sides. 4.24 square root is very close to 2.05. How? Square root of 4, 2. 0.24 means 0.20, approximate 0.25. 25 root, 5. So 0.24 is nearly 0.05 is equal to root of x square, x, 0.1 minus x square, 0.1 minus x, taking square root on both sides. Now I think it will be easier, right here all. So substitute here, we can get it 2.05 into 0.1 minus x equal to x, and simplify the value of and calculate the value of x here all. It's simple, So after the calculation, you will get x is equal to 0.067 molar. You will get the value of x equal to 0.067. What is that x? It is the concentration of carbon dioxide and hydrogen. So carbon dioxide concentration, hydrogen ion concentration is equal to 0.067 that we found. What about reactant? 0.1 minus x. So subtract this value from 0.1. 0.1 minus 0.067 equal to, that is 0.033. So value of or concentration of carbon monoxide and hydrogen is 0.1 minus x, that is equal to 0.033 molar. So in this type of question, how to do the experiment, how to do the question? Write the equation. Initially, how much you have? Initially, you have only reactant, no product. At equilibrium, XX amount formed means that's, so it's subtract from here 0.1 minus x, 0.1 minus x, apply into Kc, make a quadratical equation, or by, if it is simplified by this method, apply this one, find the value of x and substitute here. That is the concentration calculation at equilibrium. Clear all? Next question. For the equilibrium, the value of the equilibrium constant, see given, Kc is given, Kc is equal to 3.75 into 10 raised to minus 6 at a temperature of 1069 Kelvin. 1069 Kelvin. Calculate the Kp for this reaction. Kp, Kc relation we know. If you want Kp, we need the value of delta Ng also. What is delta Ng, dear all? How many gaseous product you have? 2 moles plus 1 mole. Total 3 moles minus. How many moles gaseous reactant? 2 mole. 3 minus 2, 1. Substitute the value. We have Kp equal to Kc into RT raised to delta Ng. How to do that? Kp is equal to, Kc is given 3.75 into 10 raised to minus 6 into, what is R value? Dear all, universal gas constant R value you may studied 0.082 or 0.0831 in terms of what? Bar, liter, Kelvin inverse, mole inverse. Right? So the R value, universal gas constant, we can take it as 0.083 bar, liter, Kelvin inverse, mole inverse. So 0.083 into, what is the temperature? Temperature is already given 1069. Right, 1069, and delta Ng is already 1. So calculate the value of Kp, all of you. Take time and calculate. Don't use calculator. Take time and calculate it. Kp value, you will get it around 0.033. 0.033. So Kp, Kc related numericals are very sure question. Okay. So calculate delta Ng from the equation. Substitute directly. Clear all? Next question. The value of Kc for the reaction. Here also Kc is given 2 into 10 raised to minus 3. And the composition reaction at a given time. Kc already given. Kc means at equilibrium. They calculate. They already given. At a given time, the composition of the concentration of A, B, C, all are given, all are same. In which direction reaction will proceed? Dear all, how to predict the direction of a reaction? By checking the value of Kc and Qc. We have, if Qc greater than Kc, if reaction quotient greater than equilibrium constant, we studied that backward reaction takes place. And Qc less than Kc mean forward reaction takes place. In Qc equal to Kc, reaction is at equilibrium. reaction is at equilibrium. So this is the way you can predict the direction of the reaction. Okay, so QC greater than KC mean backward, QC less than KC mean forward, QC equal to KC mean reaction is at equilibrium. So we have to find the value of QC because KC already given. How to calculate QC, dear all? QC is same, product concentration by reactant concentration. What is the products in this question? B and C are the product, right? So concentration of B, concentration of C, concentration of, what is the reactant? 2A, that means A square. What is the concentration of B? 3 into 10 raised to minus 4. What is concentration of C? That is also 3 into 10 raised to minus 4. By what is A concentration? That is also 3 into 10 raised to minus 4 the square. See, this is 3 into 10 raised to minus 4 square by 3 into 10 raised to minus 4 square. We can cut it, is equal to 1. So QC is equal to 1. Compare the value, dear all. KC is 2 into 10 raised to minus 3, but QC is 1. Whether KC or QC, which is bigger? QC. QC is bigger, right? QC is bigger, KC is smaller. So which reaction takes place? Backward reaction takes place. And one more question. What is the difference between KC and QC? Dear, calculation wise both are same. Product by reactant. KC you can calculate only at equilibrium. Therefore, it's called equilibrium constant. But QC we can calculate before or after equilibrium at any time. Okay, so therefore QC you can calculate at any time, between before equilibrium or after equilibrium. At equilibrium, the one which you are calculating, that is called equilibrium constant KC. Clear all of you? So remember this point, okay? KC, QC, the relation. Next, hydrolysis of sucrose. Sucrose on hydrolysis getting glucose and fructose. Equilibrium constant KC is already given 2 into 10 raised to 13. At 300 Kelvin. So temperature is also given 300 Kelvin. Calculate Gibbs free energy, standard Gibbs energy. What is the equation connecting Gibbs energy and equilibrium constant? Gibbs energy equal to minus 2.303 RT into log Kc. Direct substitute equal to minus 2.303. What is the R value? R value not mentioned here, right? Yeah, dear all. This is energy term. Gibbs energy, right? Energy terms, when you using universal gas constant, R value is 8.314 joule, Kelvin inverse, mole inverse. This is the unit. Before we taken 0.083, that is in bar liter, but this is in energy. See, joule. Energy related any numerical, especially thermodynamics chapter and all, we are using this term, this value, because energy term R value is 8.314. Substitute 8.314 and temperature is around 300 into log Kc. What is Kc? 2 into 10 raised to 30. Dear all, directly do the calculation. This one you can do it. So take time and slowly do it. What is log 2 into 10 raised to 13? You know, this is log A into B. As I told you, log A into B is log A plus log B. So log 2 plus log 10 raised to 30. What is log 2? We discussed before, right? Remember 0.3010. And log 10 to the power 13 is what? 13. Here, actually log 13 is given, we don't want that, to confuse the question. Okay, so log 2 into 10 raised to 13 is log A into B. Log A into B is what? Log A plus log B. So log 2 plus log 10 raised to 13. Log 2 is 0.3010 plus log 10 raised to 13 is 30. So it is equal to what? 13.3010. Substitute here. Final answer of delta G will be minus 7.64 into 10 raised to 4. Unit, don't forget, joule per mole. Okay, Gibbs energy unit, joule per mole. So direct equation, log, just apply there. Clear all? Next question. The species H2O and HCO3 minus, HSO4 minus, and ammonia NH3. Question, for each case give the conjugate acid and conjugate base. Dear all, conjugate acid and conjugate base, if you want to get, very simple method, if you want to get a conjugate base from a compound, right? If you want to get a conjugate base from a compound, remove one H plus. Okay, if you want, remove one H plus ion. Similarly, if you want a conjugate acid from the species, add one H plus. Add one H plus. So can you tell me the answer? To H2O, if you add one H plus, it becomes H3O plus. From H2O, if you remove one H plus, it becomes OH minus. Yes or no? Okay, so conclusion, if you want a conjugate base from an acid, remove one H plus. If you want a conjugate acid, means add one H plus. In HCO3 minus, to which add one H plus, you will get H2CO3. This minus and the H plus plus cancel. And from HCO3 minus, remove one H plus, what you will get? CO3 2 minus. Why 2 minus? Already one minus is there. If you remove this H plus ion, that minus also get it. And add one H here, you will get H2SO4, remove one H plus, you will get SO4 2 minus. Here add one H plus, it becomes NH4 plus, remove one H plus, that become NH2 minus. Okay, this is the way we can able to get the conjugate base and conjugate which one? Acids. Clear all? So conjugate base, conjugate acid, add one H plus, remove one H plus. Remember that point. Next one, classify the following species into Lewis acid and Lewis base. Dear all, you know Lewis acid, Lewis base. Lewis acids are electron deficient compound. Electron deficient. So they will accept electron pair because they are electron deficient. Lewis bases are electron rich compound. So they can donate electron pair. Got the difference? Okay. So Lewis acids are electron acceptors because they are electron deficient. And Lewis bases are electron rich. They can donate electron. So classify them as Lewis acid and Lewis base, right? See the species are OH minus, F minus, H plus and BCl3. Check it out. There are OH minus, negative charge. F minus, negative charge. There are negative charge indicate that they have more electrons. See, you know, this oxygen carry lone pair, right? Oxygen carry lone pair, you know, fluorine carry lone pair. Lone pairs are there in this negatively charged species. So they can donate easily. So they are electron pair donor. So they donate electron pair because they are electron rich. So they act as Lewis base. What about H plus? Dear all, H plus mean they already lose electron. They are electron deficient now. Electron deficient compounds are what? Lewis acid. Okay, what about BCl3? That same question we discussed in BF3 also. You know, BCl3 mean the central atom boron, only 3 bonds are there. You know, 3 bonds contain 6 electron. So this boron is electron deficient. It do not complete the octet. So this BCl3 is what? Electron deficient compound. Since it is electron deficient, it tried to accept electron. So this also acts as what? Lewis acid. So generally, if lone pair or negative charge is there, generally, okay, general common. If lone pair or negative charge is there, they are electron rich. So they can easily donate. They are Lewis base. Generally, positively charged species and electron deficient species are which one? Lewis acid. Clear all? Next one. Derive the relation between Kp and Kc. You may study the derivation. It's a 2-3 mark question for your exam. Let me discuss once again. You know the relation Kp equal to Kc into RT raised to delta Ng, right? Good. Let's go for that one. I'm starting with an equation. General consider a reaction. AA plus BB is equilibrium with CC plus DD. For this reaction, I can write Kc is equal to C raised to C into D raised to D divided by A raised to A into B raised to B. For this reaction, I can write Kp also. If all reactants and products are in gaseous state, instead of Kc, what we can write? Kp. How to write? Pressure of product into pressure of product divided by pressure of reactants. Okay. Kp, Kc we written. Take ideal gas equation or consider ideal gas equation. You know PV is equal to nRT. Consider ideal gas equation PV equal to nRT. From which P equal to N by V into RT. P equal to N by V into RT. What is number of moles by volume? Number of moles by volume mean molarity, concentration. So I can write P equal to CRT. Once again, dear all, ideal gas equation PV equal to nRT from P equal to N by V into RT, where number of moles by volume is concentration, that's molarity, CRT. If P equal to CRT, what we can write, dear all? We can write what is PA, what is PB, what is PC, what is PD. What it is? If P equal to CRT, I can write PA equal to concentration of A into RT. If P equal to CRT, concentration into RT mean, I can write concentration of B into RT, concentration of C into RT, concentration of D into RT. Clear all? After that, so we got the expression for all PA, PB, PC, PD. Substitute in this equation. What is Kp now? It become, so Kp is equal to Pc raised to C. What is Pc? Concentration of C into RT raised to C. What is PD? Concentration of D into RT raised to D divided by, what is the other one? Concentration of A into RT raised to A, concentration of B into RT raised to B we substituted. Clear all? From which what we can take it out? Kp equal to, let me take C raised to C out and D raised to D out, A raised to A out and B raised to B out into, what is left in the numerator? RT raised to C plus D and here RT raised to A plus B. Correct. What is this term, dear all? C raised to C, D raised to D by A raised to A and B raised to B. That is Kc. So yes, we got the relation Kp equal to Kc into RT raised to, what we can write this one? C plus D minus A plus B. Correct. So Kp equal to Kc into RT raised to, what is the C plus D minus A plus B? Coefficient of gaseous product minus coefficient of gaseous reactant. That is what? Delta Ng. So this is the relation. Okay, dear all, pause the video just to once again just try to get the derivation. Hope it's clear, dear all. Just go through that. Okay. Next question. Calculate the solubility of A2X3. You know, A2X3 when break, what you will get? 2A 3 plus and 3X 2 minus. Correct all? Yes or no? Just check it. Okay. A2X3 when break, you know, this 3 come from A, this 2 come from this X. So 2A is there. So 2A with the charge 3 plus and 3X charge 2 minus. You know, how to write the solubility and solubility product? Carefully listen on. How many A3 plus formed here? 2A, right? So its concentration, take it as 2S. If it is 1 mole, 1S, like that. Here how to write? Here 3 moles X form. Therefore, its concentration is 3S. What is S represent? Solubility. So I'm going to write the expression for KSP. What do you mean by KSP? Solubility product. Solubility product. Solubility product is the product of the product side. What is the product? You have A3 plus square into X2 minus cube. Here all solubility product is KSP and S represents solubility. Solubility is something but it's concentration. So whenever you're writing KSP expression, only write the products of products, means products of products. Okay, and the coefficient, take it as the power. What is the concentration of A3 plus is given 2S. So 2S cube, square into, what is concentration of X, that is 3S, right? So 3S square. 3S cube. Correct or not? Here concentration of A3 plus is 2S. 2S square into 3S cube. It's equal to 2S square is equal to 4S square. Right? 4S square into 3 cube 27 S raised to cube. It will be around 108 S raised to 5. KSP, I think KSP already given in the equation 1.1 into 10 raised to minus 23. Clear all? So we wrote A to X3, A to X3 breaking as 2A3 plus and 3X2 minus. Concentration of A is 2 moles are there, therefore 2S. Here 3 moles are there, therefore 3S. This is a concentration, okay? 2S and 3S are the concentration. Whenever you're writing solubility product, only take the product of products. So this products, A concentration substituted, B concentration substituted, we got like this. We want to calculate the value of S, that's a question, correct? So let us simplify, it's a normal one, simplify. So S raised to 5 equal to 1.1 into 10 raised to minus 23 divided by 108. That you will get it around 1 into 10 raised to minus 25. Direct NCERT question, just simplify all of you. You will get 1 into 10 raised to minus 25. This is S raised to 5, right? So S raised to 5 equal to 1 into 10 raised to minus 25. So S will be equal to 1 into 10 raised to minus 5. That's the answer in terms of mole per liter. So solubility product calculations are most expecting. So the given thing, what is the given thing here? Let me give you another example. Suppose PbCl2, lead chloride when break, what do you get? Lead 2 plus and 2Cl minus. How to write this one? Here 1 lead form, therefore solubility S. Here 2 chlorine form, therefore solubility 2S. How to write the KSP expression? That is product is Pb2 plus and Cl minus square. What is the concentration of lead? S. What is the concentration of chlorine? 2S square. That's equal to 4S cube. Like that. This is the way to answer. So they will give you KSP, maybe they ask you solubility. Maybe they give you solubility, they ask you KSP. This is the type of question from this area. Okay, clear all? Next one we have, what is Kc for the following reaction in state of equilibrium? Very simple question. They already given equation, they are asking what is Kc. What is Kc? Product concentration. What is product? SO3 square by SO2 square into O2. Substitute the value. SO3, what is the concentration? 1.9 square by, what is SO2 concentration? 0.6 square into, what is O2 concentration? 0.82. They're all calculated. You'll get around 12.229 liter per mole. Okay, that's mole per liter. So that is the concentration. You will get mole per liter. Okay, so Kc is equal to this direct substitution, right? Kc equal to product concentration divided by reactant concentration. What are the product? What are the reactant? Directly substitute. Next one. Which of the following is not a general characteristics of equilibria? You may study what are the general characteristics of equilibria. For every chemical equilibrium reaction, there will be a fixed Kc value. When you're reversing the Kc value, you know it becomes reciprocal and all. And equilibrium can be achieved in a closed system. And equilibrium is dynamic in nature. What do you mean by dynamic in nature? Rate of forward reaction equal to rate of backward reaction. These are the general characteristics of equilibrium. Question which is not a general characteristic. What is answered here all? That is option C. The measurable properties of the system keep changing. You know, at equilibrium, the measurable properties like concentration, temperature, pressure, these all what remain the same one, right? It won't change. Next one. For the following reaction, value of Kc is given. See all of you, this is the reaction given here. Its Kc value given as 8.2 into 10 raised to 4. Okay. For this reaction, Kc value is 8.2 into 10 raised to 4. Question. If so, what will be the value of Kc for the reverse reaction? You know that when you reversing a reaction, the Kc value will be, the new Kc value will be reciprocal of the first one. So it will be 1 by 8.2 into 10 raised to 4. That is option B. What is the point all of you? What is the point all of you? If you have an equation, for example, AA plus BB gives CC plus DD, where Kc value, suppose it is equal to X. Okay, if you are reversing the equation, that means CC plus DD gives AA plus BB. If you are reversing, the new Kc value will be 1 by X. One more point. Suppose I am multiplying the first equation by a value n. That means n a raised to a plus n b raised to b equal to n c raised to c into n d raised to or d d. NCC and DD. If you multiplying the first equation, what is the first equation Kc is x. If you multiplying the first equation by a value n, the new Kc will be x raised to n. Means the one which you multiply, the which number you use to multiply the equation, it will be the power of that value. Okay, let me give you some more example. The value of equilibrium constant Kc for nitrogen hydrogen with ammonia is forming ammonia. For this reaction Kc value given 7. Okay. If so, what is the Kc value of this? See what happened here. They multiply this equation by 2. Check it all of you. They multiply this equation by 2, right? It becomes 2n2, 6h2, 4nh3. As I told you, if you multiply the equation with a value mean, the value become as a power. So, you beginning equation Kc value 7. If you multiply with the 2 means, it becomes 7 square. That's equal to what? 49. That is option A. Correct? Next one. Which of the following is an example of homogeneous equilibrium? What do you mean by homogeneous and heterogeneous? See dear all. If all reactants and products are in same phase. If all reactants and products are in same phase, it's called a homogeneous equilibrium. If all reactants and products are not in same phase, means solid, liquid, gas, then it is called heterogeneous equilibrium. So let us consider which of the following is an example of homogeneous. Means all reactants and products should be in same phase. Which is that? That is option A, right? See, this reactant is in gas, this reactant gas, even product also gas. Say all reactants and products are in gaseous state, mean it is homogeneous. What about this one? This is solid, gas, gas, gas. See, the solid gas mixture is there. So all reactants and products are in same phase, mean that is what homogeneous equilibria. Next. For which of the following reaction Kp equal to Kc? We already said in one another question, when Kp equal to Kc, when delta Ng equal to 0. Check which equation delta Ng is 0. First equation you check it all. First equation, how many gaseous product you have? Only one gaseous product, 1 minus. How many gaseous reactant you have? 1 plus 1, 2. That's equal to what? Minus 1. Here delta Ng is not 0, right? Okay, not leave it option A. What about option B, dear all? In option B, calculate delta Ng is equal to, how many gaseous product you have? 2 moles, 2 minus. How many gaseous reactant you have? 1 plus 1, 2 mole. Yes, here delta Ng is 0. Where delta Ng is 0, where Kp equal to Kc. So option is what? B. Hope it's clear. Next one. A numerical question. At 350 Kelvin, so temperature is given 350 Kelvin. Kp for the reaction, Kp is given as 3 into 10 raised to 10 bar inverse. Okay, bar inverse at equilibrium. What will be the value of Kc? Okay. Equation already given. Equation given mean immediately calculate what is delta Ng. How many gaseous product you have? 2 moles you have minus. How many gaseous reactant you have? 2 plus 1, 3 moles is equal to minus 1. Okay. So what is the equation for Kp and Kc? Kp equal to Kc into RT raised to delta Ng. Substitute all of you. Kp is 3 into 10 raised to 10. Okay, 3 into 10 raised to 10, and Kc is supposed to calculate. What is the value of R? R value we discussed before, that is 0.0831 bar liter Kelvin inverse mole inverse. So we can substitute 0.0831 into temperature is 350. What is delta Ng? Minus 1. So it becomes the reciprocal. So find the value of Kc. Kc is around 8.715. This is the option. Option D is the correct answer. Clear all? So these type of questions. So Kp, Kc related, see how many, around 3-5 questions we were discussed. The numericals are very important. Kp, Kc relation and the Kp, Kc numerical also all are very important question. Okay. So keep doing the question all of you. Next one. The expression for equilibrium constant Kc for the following reaction is, what is expression? Simple question. Kc equal to, what is Kc dear all? Kc is equal to product concentration divided by reactant. But what is a product dear all? Product is actually FeOH thrice, it's a solid, by what is the reactant? Fe3 plus aqueous and OH minus cube. Right? See, I told you molar concentration of solid, we take it as 1. So this is a solid, right? So its concentration is equal to 1. So the answer is which one? Option C. 1 divided by Fe3 plus into OH minus the power 3. Concentration of solid, we take it as what? Unity. That's it. Next one. N2O4 gives to NO2. Kc is given. See, for this reaction, Kc is given at 298 Kelvin at equilibrium. Which concentration will be more or less like that? Already we discussed this question in another way. By looking the value of Kc, we can able to predict whether product or reactant is predominant. Do you remember that? If Kc value greater than 10 cube, we said products are more than reactants. Kc value less than 10 raised to minus 3, reactants more than products. Yes or no? And Kc between means a appreciable amount. See, this Kc value, I think it is less than 10 raised to minus 3. Yes or no? This is 10 raised to minus 9. See, this Kc value is less than 10 raised to minus 3. So, reactant should be more than product. What is a reactant? Reactant is N2O4. So, we can able to say concentration of N2O4 is higher than NO2. That is option B. So, by checking the value of Kc, we can able to predict which will be more, which will be less. Clear all? Next one. State Le Chatelier principle. A must question from the chapter. What is Le Chatelier principle? Definition you may studied very well. When a system is in equilibrium, if you make any changes in concentration, temperature and pressure. What are the main factors affecting equilibrium? Concentration, temperature and pressure. Dear all, are you focusing? Okay. Le Chatelier principle says that when a system is in equilibrium, if you make any changes in concentration, temperature or pressure, equilibrium get disturbed. So the system itself try to nullify the change and it's try to bring a new equilibrium is called what? Le Chatelier principle. Once again, when a system is in equilibrium, if there are any changes happen in concentration, temperature or pressure, equilibrium get disturbed. So the system itself try to nullify the change and bring a new equilibrium. This is called what? Le Chatelier principle. Definition question, theoretical questions are there. Let's see. How can we increase the formation of ammonia in Haber process by changing? Dear all, Haber process is nothing but nitrogen combined with the hydrogen, we get ammonia. This is called what? Haber process. One more thing. In Haber process is an exothermic reaction. They will give you delta H with a negative sign, which indicate that it's an exothermic reaction. This is what Haber process. Okay. Nitrogen combined with the hydrogen, we get ammonia called a Haber process. Question. Through this reaction, how can you increase the formation of ammonia? This is forward reaction. This is backward reaction. If you want to get more amount of ammonia, which reaction we need to get more? Forward reaction need to happen. In order to get forward reaction more, what all changes you can do it? Dear all, first, what you can do in concentration? You can increase the concentration of reactant. So, increase the concentration of nitrogen and hydrogen. Increase the concentration of which one? Nitrogen and hydrogen. If you increase more reactant in order to balance that reaction shift to forward, you will get more ammonia. Or you can see that decrease the concentration of ammonia. If you decrease the concentration of ammonia, concentration always shift from higher concentration to low concentration. If you decrease product side, reaction shift this way, you will get more amount of ammonia. So forward reaction reaction you can increase always by increasing reactant concentration or decreasing product concentration. Clear all? Second question. What term in pressure? Temperature. Keep in mind all of you. For an exothermic reaction, when you increase temperature, reaction shift backward. Apply for all reaction, okay? If it is an exothermic reaction, when you increase temperature, backward happen. If it is decreased temperature, forward happen. Just opposite for endothermic, okay? This is an exothermic reaction. We need actually forward direction. So if you want a forward reaction for an exothermic, mean decrease the temperature. So in temperature, decrease the temperature. What about last? Pressure. Pressure effect is like this, dear all. Pressure, if you increase the pressure, reaction shift from high number of moles to low number of moles. High number of moles to low number of moles. If you increase the pressure of a system, reaction always shift from high number of moles to low number of moles. Check it all. How many moles left side you have? You know, these all are gases, right? Here you have 1 nitrogen, 3 hydrogen, total 4 mole. And products ammonia, it's 2 mole. See, if you increase the pressure, reaction shift from higher moles to low mole. Yes, that's what we need. Forward reaction takes place. So as per this question, pressure increase. Okay. If you want to get more amount of ammonia through Haber process, increase the concentration of reactant or decrease the concentration of product. And if you want to get more amount of ammonia or forward direction, what you can do in temperature, since it is an exothermic reaction, we have to decrease the temperature for forward. And pressure, check the number of moles left and right. Gaseous, okay, only gaseous. If higher moles to low moles, always reaction shift if you increase the pressure. So these are the set of conditions to make more amount of ammonia here. Let's see more question. Which of the following reaction will not get affected by increase in pressure? I told you, if you increase the pressure, generally reaction shift from higher number of moles to lower number of moles. Correct or not? Yes, right? But there is no effect of pressure, mean there is no change in number of moles. Both reactant and product, equal number of moles should be there. Where it is, dear all? Here 2 plus 1, 3 mole. Here 1 mole. It's unequal. Here 4, check it all gases. Okay, it should be gas. Don't count the solid and liquid system. Only gas. All are gas here. So 4 plus 5, 9 moles left side. 4 plus 6, 10 moles right side. Not equal. Here 1, here 2, 1 plus 2, 3. Here 1 plus 2, 3. Yes, here 3 moles left and right. Equal number of moles on left and right mean no effect of pressure. That is option C. So what is the conclusion all? If the system having equal number of mole, there is no change in or there is no effect of pressure. One more factor you remember, dear all, catalyst and noble gases. Catalyst and noble gases do not affect equilibrium. Okay. What is the only 3 factor affecting equilibrium? Concentration, temperature and pressure. Catalyst, they will say, what happened? Neon gas applied. Nothing happened. Neon is a noble gas. What happened? Catalyst added. Nothing happened. You know, catalyst and noble gas do not affect equilibrium. Please note that. Next one. In which of the following reaction the increase in pressure will favor the product? Favor the product mean forward reaction should happen. Increasing pressure mean I told you always reaction shift from higher number of moles to lower number of moles. Check. How many moles left side? 1 plus 1, 2 moles. Here also 2 moles. Same moles mean no effect of pressure. Leave it. How many moles left side here? 1 plus 1, 2 mole. Here only 1 mole. Yes. In this reaction, if you increase pressure, reaction shift from higher moles to low moles. Forward will happen. Yes, option B is the correct answer. Clear all of you? Good. Next one. Another question. This reaction, you can able to see 2SO2 plus O2 gives 2SO3 plus heat. Dear all, heat mentioned product side mean it is exothermic. It is exothermic. Will be favored by. And they're all are gases, okay? These all are gases. All are gases. Okay, perfect. Let's see, dear all. Can you say, if you want to take this reaction more, whether will you decrease the temperature or increase the temperature? See, it is an exothermic reaction. Come. Exothermic reaction mean as temperature increases backward, temperature decreases forward. You want forward, right? If you want forward mean temperature decrease for an exothermic reaction. What about pressure? Pressure means check number of moles. How many moles left side? 2 plus 1, 3 mole. How many mole right side? Only 2 mole. If you increase the pressure, reaction shift from higher to lesser. Yes, that we need. So, low temperature, high pressure, prefer it. Low temperature and high pressure. Clear all of you? Hope it's clear. According to Lewis concept, an acid is a. You know, Lewis acid, Lewis base, we said. Lewis base mean electron pair donor. Lewis acid mean electron pair acceptor. So, Lewis concept, they are electron pair acceptors. Okay, electron pair acceptors, Lewis acid. Okay, next one. Which of the following is not a Lewis acid? Not a Lewis acid. Which of the following is not a Lewis acid? What do you mean by Lewis acid? They should accept electron, correct? They should accept electron. See, BF3 case we already discussed. This is BF3. This is AlCl3. This is FeCl3. Okay, and this is PH3. PH3, you know, phosphorus contain a lone pair. Like NH3. PH3 is like NH3. They're all BF3, AlCl3, FeCl3. See the central atom is electron deficient. Why? Because it contains only 3 bonds. 3 bond means 6 electron, not complete octet. A, B, C are electron deficient. So what they do? They try to accept electron. So they are Lewis acid. But PH3 contain a lone pair. They can donate a pair of electron. This is the only one Lewis base. So question which is not a Lewis acid, that is option D. Check the next one. Which of the following is a conjugate acid of SO4 2 minus? You know, SO4 2 minus. How you get conjugate acid, all of you? Add 1 H plus. If you add 1 H plus, it becomes HSO4 minus, right? So what is that? Option A. So if you want conjugate base, remove 1 H plus. If you want conjugate acid, add 1 H plus. Correct? Next one. Which of the following species act as both as an acid as well as base? Which one can act as both acid and base? Can you able to say? SO4 2 minus, PO4 3 minus and all we can immediately cut it because there is no hydrogen to lose, right? There is no proton. But HSO4 and OH is there. But OH, which one can be the answer? B, right? You know, HSO4 minus, you can add 1 H plus and also you can lose 1 H plus, right? If you add 1 H plus, it becomes H2SO4. If you remove 1 H plus, it becomes SO4 2 minus. It can give conjugate base and conjugate acid. So HSO4 minus can act as both acid and base. What will be the pH of 1 into 10 raised to minus 4 molar H2SO4. Very careful. Don't go to immediately the value, dear all. Check the acid. H2SO4 can give you what? 2H plus ion, right? H2SO4 can give you 2H plus. So 2H plus is there. So H plus concentration how much? 1 into 10 raised to minus 4. So here we can 2 into 1 into 10 raised to minus 4 is the concentration of H plus. Why? Because it's giving 2H plus ion. This is H plus ion concentration, but H2SO4 give you 2H plus. So 2 into 1 into 10 raised to minus 4. That is 2 into 10 raised to minus 4. So what is the equation for pH? pH equal to negative log of H plus concentration. So negative log of 2 into 10 raised to minus 4. Negative. What is log A into B? Log A plus log B, right? Log 10 raised to minus 4. How to simplify this one is equal to negative of log 2, hope you remember the value, 0.3010 plus log 10 raised to any value, the value is the answer. So equal to 4 minus 0.3010 is equal to around 3.7, right? It's around 3.7. So pH calculation, while calculating, be careful. Which acid is the check it? For HCl, HNO3 and all, it will give only H plus ion, 1 H plus ion. So it can take the given value. But H2SO4 will give you what? 2 H plus ion. So 2 into the given concentration. Okay. So answer is what? 3.7. Next one. What are buffer solution? Give example. Dear all, what are buffer solution? They are solutions have an ability to resist the change in its pH, even by the addition of some small quantity of acid or base. See, our blood is an buffer solution. See, we are eating so many things like acid, bases, many things we are eating. It do not affect the pH of our blood, because pH, the blood have an ability to resist the change in its pH. So what are buffer solution? These are solutions have an ability to resist the change in its pH, even by the addition of some small quantity of acid or base is called buffer solution. And you may study there are two type of buffer solution. What are they? Acidic buffer and basic buffer. Acidic buffer and basic buffer. What are acidic buffer? Nothing but their pH value is less than 7, and basic buffer pH value greater than 7. One more thing, how to get an acidic buffer? Acidic buffer is getting by the combination of a weak acid and its salt. Weak acid and its salt. For example, a weak acid, for example, acetic acid, right? Acetic acid. Its salt, which one? CH3COONA, sodium acetate. So acetic acid, if you mix with sodium acetate, it can give you what? Acidic buffer. So acidic buffer is formed by the combination of weak acid with its salt, and basic buffer is formed by the combination of weak base with its salt. For example, weak base example, ammonium hydroxide, its salt is ammonium chloride. Okay, ammonium hydroxide and ammonium chloride. So this is, so study here what is buffer solution, what are the type of buffer solution, and example. Let me show you one MCQ. An acidic buffer solution can be prepared by mixing the solution of, as just told you, acidic buffer is prepared by the combination of weak acid and its salt, which is that sodium acetate and acetic acid. Sodium acetate and acetic acid. Okay. One another important question, dear all, direct question for your exam. Define common ion effect. Let me explain with a simple example, okay? Carefully listen all. Definition already given here. Let me take a weak electrolyte. For example, ammonium hydroxide. It's a weak electrolyte. It's a weak electrolyte. This ammonium hydroxide is undergoing dissociation. Dissociation means what? Splitting into their ion. So forward reaction, I can say dissociation of ammonium hydroxide. Ammonium hydroxide, when break, what do you get? Ammonium ion and hydroxide ion. So here weak electrolyte, ammonium hydroxide, dissociate, give its ion. So what is the backward reaction? We can call it as suppression. Suppression of dissociation of weak electrolyte, right? Suppression of dissociation of weak electrolyte. Means forward reaction means more dissociation happen, mean backward reaction they are suppressing the dissociation, correct? Why I use the name is this is involved in the definition. Okay, so what you have in the beginning in the solution, dear all, in the beaker, beginning ammonium hydroxide I put in water, it's give you which all ion? Ammonium ion and a hydroxide ion. Okay, to the same beaker, I'm going to add a strong electrolyte, ammonium chloride. Okay, I'm going to add ammonium chloride. Keep in mind, it's a strong electrolyte. You know, strong electrolyte will undergo complete dissociation in water. It will give you ammonium ion and Cl minus in large amount. So to the same beaker I'm adding. Okay, so to the beaker, what all ions are getting more? NH4 plus and Cl minus. Okay, so what you have in the beginning, all of you? A weak electrolyte you have. Weak electrolyte, when splitted, you will get its ions. Forward reaction called a dissociation. So backward reaction called a suppression of dissociation of the weak electrolyte. To the same beaker, we added strong electrolyte. What is a strong electrolyte? Ammonium chloride. It's give you ammonium ion and chloride ion. So overall in the beaker, whose concentration increased? Ammonium ion concentration increased. Yes or no? Why ammonium ion concentration increased? Due to the addition of strong electrolyte. Correct or not? Listen. Check the first equation. See, ammonium ion concentration when increases mean product increases mean as per Le Chatelier principle which reaction takes place. See, product concentration increases mean backward reaction takes place. What is the name of the backward reaction? Suppression of dissociation of weak electrolyte. This thing, can you make it as a definition? Start. Common ion effect is the suppression of dissociation of a weak electrolyte by the addition of a strong electrolyte which contain a common ion. See, why this? What is the name of the backward reaction? Suppression of dissociation of weak electrolyte. Correct? How it is happen? Due to the addition of a strong electrolyte. Correct? This, and they contain what? A common ion. Which is the common ion in both of them? Ammonium ion. Make it your definition, dear all. It is the suppression of dissociation of a weak electrolyte by the addition of a strong electrolyte which contain a common ion. This is called what? Common ion effect. Is it clear all? So this chapter, equilibrium chapter, basically contain the factors which all Kc, Qc relation, their applications, many factors are there. Le Chatelier principle, how concentration, temperature, pressure and all affecting the equilibrium, and how to calculate the solubility, product and solubility, Ksp, the equations and all. How Gibbs energy, Kc are related, how Kp, Kc are related. By looking the value of Kc, which one is dominated, we can able to say. By looking the value of Kc and QC, we can able to say predict the direction of a reaction. While multiplying the a balanced a reversible equation, what happened to the change of Kc value? That all points we discussed. What are acidic basic concepts? Arrhenius, Lowry Bronson, Lewis concept, which is Lewis acid, which is Lewis base, like that. And what is the conjugate base? What is conjugate acid? Like common ion effect, many factor buffer solutions are like we studied in this chapter. So these are the most repeated type of question or the concept for your upcoming examination. Hope you understood the questions and try to practice again, dear all. And what all the doubts you have, please comment in the chat. You can comment in our portal. Always welcome for that, and wish you all the very best. Practice your level best. Thank you all. We will meet again with another chapter, another important chapter in the upcoming session. So thank you all. Bye.